2. I guess it's part 2. It's not really part 2, but a continuation of our block series where I use this block of a steel beam to create different things. So in the first video of this series, I have just made this simple script here where you press the little button and it places the beam on any kind of a curve that you want. And you can do some weird shenanigans with it if you just play around with the curves. You, let's say, tween them. Yeah, sure, let's go for 25. Why not? Right? Add all of them in here, press play. You know, you get something very, very funky here. In this video, we're going to actually put this definition to good use, and we're actually going to make something with it. So if you haven't followed along the previous video, I suggest you do watch it, link in the video description below, just so that you're up to speed. It's basically, you need this block instance here that is called a beam. So actually, let me delete it and let's make a building envelope first. But there are many ways of how you can create a building envelope. The one that we're gonna use is gonna be a pretty damn fast one. We're gonna use quads to define it. So follow or repeat after me. Let's make a mesh. Let's make actually a mesh box. And let's say the Z count of the mesh box. So you go to mesh tools and here you select mesh box. Now you're with me. Z count of mesh box is, let's go for 5. If we need to, we'll add more. So it's 5. Y count of the mesh box is, let's say, 3. And X count is 3. 3, 3, 5, right? Start from 0. And just draw out, not with numbers. We will type in the measurements. Let's go for along the X direction. Let's go for 15,000 millimeters, which is 15 meters. Then Y direction, 15,000 millimeters, which is 15 meters. And Z direction, 5 times 5, 25,000 millimeters. Right? We get this little box thing here. Nothing fancy, just a box. All right, so with it done, I will Control Shift and select one side of it, like this, and just get rid of it, just delete it. And I'll Control Shift, select the back side of it, and delete it as well. I only care about the loop here. This loop right here. By the way, if you are curious about the red thing, whatever it's called, like the red backside color, you can access it by going to the display tab. If you don't see the display tab, you need to click on this gear icon here and tick mark it. But you go to the display tab, and here under object settings, you choose color back faces to be turned on and choose any color you want. I prefer red, so I go for red, right? This just helps with modeling, especially when you're modeling with thin shells. Not the point. The point is we have ourselves a loop, and now let's make something that's a little bit more closely resembling, let's say, Morpheus Hotel. Do you know Morpheus Hotel, Bazaar did? Bam, I'll put it. I'll put it on the screen if I remember to. If I don't, just check it out on Google. If I remember correctly, it's something like that, right? We bridge, so you select 1, 2, 1, 2. 2 polygons here, 2 polygons here. You type in bridge, and they get bridged between. And don't forget to use the same amount of settings or segments here. Actually, no. Actually, I'm sorry. Sorry about that. You can use less. So let's use just 2 segments to bridge. Hit OK. And this kind of a thing is created now, right? This inner bridge. And then I'll do the same thing for the bottom side. Let's go for something like that. and that, or actually maybe these two connect to this one, why not? Bridge. Oh right, it's going to complain if you try doing it. You do need it to be 2 by 2, right? So I do need it to be doing something like that. Bridge. Does that seem fine? That seems okay, right? This one goes in the middle, so it tapers there. Yeah, that seems okay. So you end up having something like this. Nothing fancy, nothing bad as well. Now when I think about it, we don't really need the top. So I'm just going to get rid of the top, delete, and we don't need the bottom. We'll be doing some other things with the top and the bottom, so let's get rid of them. This is our mesh right now, and this is going to be our test subject, so to say, on which we're going to be testing out different methodologies. Later down the line, when we need to make it more fancy, we will be able to go back in here and continue modeling, by adding more patches. I'll show you, but that's later. For now, let's flip the mesh, just like that, so that this is gray and this is red, and let's get it into Grasshopper. So I will reference it as a mesh. Right click, set one mesh, click. There we go. And now I can hide it so that it's not in the way. There we go. Okay, with that done, now we need to start defining where the beams will go. So my thought is we will have 3 components or 4 components in this megastructure type of a thing. Component number 1 is going to be beams that will follow the mesh edges here, and actually not these mesh edges, but I will use Catmull-Clark subdivision like that. Let's go for level 2. That might be too much, but let's still try it. Yeah, level 2 seems to be a little bit, like the beams are a little bit too small, so let's keep going with level 1. Catmull-Clark subdivision, right? And then I will also go for diagonalize. Diagonalize, like that. That's from Kangaroo 2, to get this kind of a aesthetic in here, right? Then all I would need to do to actually be able to use this, and let me group this portion, and just you don't need to do this. I'm just using it to showcase to you how easy it is. I can just do WBE, Weber's mesh edges, or you can just say mesh edges. That works as well, and just kind of get all of the interior and naked edges into one list. But I'm using the Weber's mesh edges, getting them into the curve component, and pressing the big button. And technically that's it. You get your trash people are here. You're getting your beam structure. The problem is the joints. The joints are just horrible with the beam structure as it is. So we need to actually work on it. We need to actually fix it, right? So that's a no-go. Delete, disconnect, and instead we need to find a strategy. So our strategy is gonna look like everywhere where, minimize that, everywhere where we have a connection point, there's going to be a small offset from it for the beams, for the joint to happen. And the joint is going to be custom made because, every angle here is custom. So let's assume that the joint is custom made, but the beams in between the joints, all of them are the steel beams that we're using here. All right. So with that done, let's go for let's get the mesh edges in here. Sure. And let's create an offset for them. So we basically want to trim off the ends of each edge, right? So if we have an edge here, we want to get rid of this point and this point. To do that, I will use evaluate length component. Evaluate length. I will use the edges. The edges will be evaluated with the evaluate length component. And we're basically looking at this one, right? Then I will say what's the length at which I want to evaluate. What's a reasonable length? 30 centimeters? So 30, 30, 30, 30, something like that? Or should it be proportion based? No, it should be fixed, right? So let's go for 30 or 300 millimeters, like that, right? And should it be normalized? No, it shouldn't, right? So it's gonna be toggle false. If it's normalized, it means the evaluate length component only works with ranges between 0 and 1. Now we can see that 300 millimeters of this particular beam is right in here, right? Meaning that to get this point, I basically need to measure the length of the curve and remove 300 millimeters from that length, subtract. And that is going to be a point which, you know, the second point on the curve, on the opposite side. So I basically just measure the length of the curve, just like that. I remove, subtract from that length, I remove this 300 millimeter gap, I guess. And I use the same evaluate length for it, right? Evaluate length. We're evaluating still the same curves, just like that. But now this is our length at which we're evaluating at. And the false statement goes into n as well. So we have our points on the opposite side as well. Great. With that done, so this is like curve evaluation part. With that done, all I need to do now is just draw a line between this point and this point. Line. Point to point. All right. Now, when I hide everything here, you can clearly see that this line, all of these lines have that offset of 30 centimeters from both sides. If I want it less, I can do, 100 millimeters, and now the offset is much, much less. Let's stay with 300. I think that's a good, that's a good balance. And we will make this more interesting quickly. So now as I connect my lines to the curve component and press bake, I can see that the beams are actually not intersecting. They're fine. Of course, we will need something in between them, but the beams themselves are absolutely... Yeah, they're fine. They're fine. They're not intersecting. Okay. So now this is where it starts getting a little bit tricky. And the trickiness comes from the fact that notice the orientation of the beams. This one versus this one. They're not following a specific rule. And especially if I show the mesh, they're not following the curvature of the mesh, meaning the beams don't have, they're following the curvature of the mesh with their length, but not with their orientation. For instance, why the hell is this beam, like its ears, its flaps, are sticking upwards, while if I rotate around here, this beam, it's like the surface area is sticking upwards, and here the flaps again, right? So it's all messed up with the orientation, in terms of the orientation. So we need to fix that. How do we fix that? Well, it ain't gonna be pretty, but it's gonna work. So let me disconnect that for a quick moment. It's gonna work, so we're okay with it. I am going to take this mesh, this diagonalized mesh, and I'm going to offset it. Offset mesh. Just like that. Then as a setting, I actually don't really care about the distance at which I'm offsetting, so I'm just going to say 100. Oops. //100. Enter. There we go. That's our distance. And for the both sides, that should be a 0. We don't mess with that. Create solid though. I will toggle this to false because I want it to be a single shell. So now we have basically 2 shells. If I zoom in, you can see here one and the offsetted version of it. So for the offsetted version of the shell, I'm going to repeat exactly the same process as what I've done here. Copy paste, drag it down, Ctrl C, Ctrl V, drag it down, and connect offset mesh to the copied version right here. Okay, so what does this give us? This gives us a pair of lines right here, 2 lines for each edge, and the second line will be used to orient our beams in the correct orientation, right? So they will all follow along these lines. So how do we do that? Well, we need to first of all get these lines and get them I'm sure I'm trying to show separating them into their own branches, because right now they're all in one list. So 800 lines here, 800 lines here. No. We need to graft the output here and graft the output here, meaning that each line will be used separately, and once we pair these up, they will find each other, or else it's just a mess, right? So that's the first thing. The second thing is getting the middle points between the 2 lines. Evaluate length, of course. Evaluate length like that. / 0.5, enter, half. And by default, the normal is set to true, meaning that it's going to give us, this is going to give us half. Half of the line length, a point in the middle of the line. English. Okay, so I'm doing it for both the bottom line and the top line, right? I have these 2 points. These 2 points will be important because these 2 points will define the vector, right? So I'm just going to create vector between 2 points. Vector A, or point A and point B. At this point you might be confused, so I'm going to start drawing. Basically, I have one line here, right? This is my line, initial line, line A. And above it, like that, and above it I have, it's basically like an offset, right? Line B. So what I'm going to do is I'm going to create a perpendicular frame on line A that is misaligned. Let's try to draw it. I have no idea how to, but let's draw a misaligned perpendicular frame. So let's say that's X, that's Y, you know, and it's like a grid situation going on, right? That was a very poor selection of color. Let's do something like this. All right, so we will do that. We'll create a perpendicular plane, and that is what we were doing before. But the problem with it is the misalignment, right? You can't, like this, you can't easily orient it because it's all done automatically. So what we do is we create a point on line A in the middle, we create point on line B in the middle, and we draw a vector here, like that, right? We create a vector, and this is that vector right here, middle point, vector. And then what I will say, okay, take this plane right here and align the plane with the nearest axis, either x or y, to this vector, right? So what it's going to do, it's going to say, okay, let's say my x-axis, let me draw this in blue this time. It says, okay, my x-axis is right here, and this new vector is right here, so I just need this to get oriented this way, meaning that the y-axis orients this way, and then the new plane definitely gets aligned to have an x-axis going from this point right here to this point right here, right? And along the curves, meaning that all of the beams will just align to the orientation of the offset, right? Or all of them will be clean in this way. Great explanation, wasn't it? So let's do it. We will use perpendicular frame, single one, perpendicular frame for these lines. So let's just move this down like that. So for line 1, actually, like that. And I'm just going to / 0 because that's the start point of the line. Technically, I could use this value, but let's keep it simple, right? / 0. We have those, let me make them bigger. Now we have those planes that I was drawing here that are misaligned. You can see that they're all messed up, but we have a vector that we can use to actually align planes, or align plane. There we go. Plane to align our perpendicular frame, plane, and the direction is our vector, like that. And see how this was before, and let me hide it, and now it all snaps to the correct, mostly the correct alignment. We're using the midpoints for the alignment, so it's mostly correct, right? So these planes now are good. We will be using these planes. Okay, great. Now, let's actually not use this anymore, but create our own. And by create our own, I mean we still need to. Actually, let's sorry about that. Let's use it. It's gonna be easier. But we're going to need to not use this portion right here, right? Because basically instead of just perpendicular frame, which is here, we're using a line plane, right? So I'm just deleting this one like that, and I'm using aligned plane right here to be rotated 90 degrees. We'll see if we need to rotate it 90 degrees. And for the curves, I use the lines, of course, right? And everything else should still work exactly the same way. So I press bake, and now I can see that all of my wait, something's off. Something's off. Why is the length? All of the lengths are 1,000, aren't they? 1 second. Yeah, that's 1,000 millimeters. That shouldn't be 1,000 millimeters. Why is it 1,000 millimeters? That and that. Notice how, let me just hover my mouse. Notice how the data tree length at the start is slightly shorter than every other one. And if I show you the data tree with param viewer, you will notice that it's all, you know, it's not the prettiest. It's not the prettiest at all. The reason for that, for this is the mismatch in the data tree addresses. And the easiest way on how you can fix it is before the merge, the scale X and orient X, you just right click on them and choose to simplify, basically getting rid of any trash that there might be left over from the operations that we've done here within the data tree address. This doesn't change the geometry one bit, it just changes the addresses. And now if I were to show you the param viewer again, you'll notice that all of the branches, you know, it's all clean, everything aligns, everything is nice. And if I press play, all of our beams are now aligned correctly with the skin of the building and are, you know, it's exactly what we want, right? It's what we want. All right. Now, with the beams done, do we... 1 second. I think we can do it this way. And this is like... This group is beam bacon. Beam bacon. Okay, with the beams done, we need to work on the in-between geometry. You know, the node geometry in between the beams. And I'm thinking of doing something a little bit more, well, not necessarily futuristic, but much more complex. And it's going to be a multi-pipe. So how do we make this into a multi-pipe? Well, first of all, I have my rotated planes here, right? Which means I have these endpoints here. I can use these endpoints here and I can use these endpoints here. Okay, cool. I also need the endpoints from, let's just look at, let's find like a good, oh, there we go. This is gonna be a great area to look at. Wait, I lost it. There we go. So since we're only dealing with the start points of the beams, I will always have just half of the endpoints to deal with. But my idea is to have, let's redraw this. So we have a beam here, beam here, beam here, beam here, right? And at this point, I have an endpoint right here, endpoint right here. What I need is, wait, do you even see it? Am I blocking that? No, I'm not blocking. Okay, great. What I need is this endpoint right here, this endpoint right here, the middle point, and then to be able to draw lines from the middle point to all of these endpoints and multi-pipe those lines into a single joint, you know? So how do we achieve that? Well, first of all, these two endpoints, right? Those can be found in the end, at the ends of each line segment. And the ends of each line segment are basically, they can be found by just using perpendicular frame for these lines, right? Like so. Let's make this a little bit tidier, like that. Perpendicular frame with t value of 1. As easy as that. Of course, these perpendicular frames, they still need to be oriented properly and so on. Like they are... oh, apologies. It's not... I'm using perpendicular frames for the offsetted versions of the lines. No, we don't use these. Sorry, we use the original lines. I need to group this and I need to color it other way. This is important. And let's make a blob outline. By the way, all files available to Patreon supporters. So if you're stuck and so on, just consider helping out the channel. Like this file will be available to you, including everything, literally everything. So let me just say main lines for beams. And these are just supporting lines, so we don't use those. We drag out from the main lines. So this wire right here, we get the endpoints and now we can see they're better, but I still need to use align plane and rotate plane on these to get them properly oriented. Or actually, do I? I don't really, I'm sorry, I don't really need to do that. Unless you, as a watcher or viewer, you will want to do something more than just multi-pipe, then we would need to. So let's just do it preemptively. Align plane, rotate plane. We just replace the input or P of align plane with the perpendicular frame right here, and it becomes, you know, well aligned with whatever we had before in this output. So these two, right? We will merge them into one, like that, and like that. So these are now merged. Let's just see if we can... 1 second. Yeah, there's no fixing this data tree, so I'm just going to flatten it, and we're going to find the grouping of these manually, right? So we're going to find like a group around each point manually and rebuild the data structure that way, which will be a little bit, you know, it's gonna cost a little bit of performance, but it is what it is. So let's deconstruct these planes like that, and we get our origin points, 1600 of them, you know, all of these points right here. Where were we looking at? Right here, these 4 points. And also I'll go all the way back here to my diagonalize. I'll create a mesh component and drag it all the way back into here, wherever I have my, you know, where I'm currently working. And let me just right click on the mesh component, wire display, hidden. I'm just gonna hide the line so that it's not annoyingly in the way. Let me group this and call this main mesh. You know, just so that we remember what it is. WBV to get the vertices component. We get all of the vertices of the mesh, and basically I will ask which points in this whole point cloud right here are closer than let's say this number plus 1 from these points, from each individual point here. So for that I will need to, okay, time to draw. I explained it poorly, so I'm drawing it. We have a mesh and we have our vertices here, and I'm just going to, you know, 1 2 3 4 5 6 7 whatever, you know, we have a bunch of vertices, and we have, so those vertices, all of these vertices are basically these ones, the ones that I have here, right? And also we have the initial mesh with the vertices here, and let me draw them in a different color, red. Let's say we have this point right here, and let's say a point right here, and so on, right? So we have this point, this point, this point, this point. Then, since I know for a fact that this distance is 300, and I want to have this group separated from this group, because this distance here is 300 as well, this distance here is 300 as well, this distance here is 300, here 300. Since I want them to be separated, all I will need to do is ask, okay, what's the distance between this point and every point? Oops, well, let's say the point is there. Every point in my in my point cloud, in this point cloud right here, and say all of the points that are closer than 300 or than 301 millimeters should be kept. All other points should be removed, right? That's the way we do it. So I'm going to graft my vertices component, and I'm going to measure the distance between my vertices component and each of these origin points. And you can see that it's, you know, it's like half a second of calculation, and it gives me 636,000 answers, because every point measures. I can actually, let me draw. I wonder if this is gonna crash my computer. Hey, one way to find out, right? Let's save it. Let's save it. Line A, line B. There we go. These are, you can't really see it, can you? But these are all of the lines, all of the distances that it's evaluating. And basically, I only care about the distances that are closer than 300. So I'm going to ask, is it smaller than 301? All right, 301. And at that point, we just use cull pattern right here. For each origin point, we will cull with the smaller statement right here. So we are initially separating out groups for each vertex of these points. Okay, cool. Now, as we've done this, I can are these points, by the way? These are points, right? Yes, these are points. Great. So now, as I've done this, I can average, or let's simplify this to make it cleaner. Simplify, and I can use average, because mathematical average of any point cloud is the center point of that point cloud. Remember this. So to get the center point, and then I can say, draw me a line between the center point and each of the corner points here. So it draws me a line, and then I can say, draw me a multipipe. Multipipe. On these lines with the node size of, I don't know, 6 centimeters, maybe. That was a wrong thing to connect. There we go. And it does exactly that. And we have ourselves connections. Let me custom preview this, make it a little bit nicer. Swatch. Maybe not that. A little bit towards gray. Great. Hide that. There we go. And of course, hide the planes. So now if I look at it in the Arctic view, what else is still visible? That in the Arctic view, you can see that we have custom connections for every single beam joint. Great. We're not done yet. We're not done yet. We continue working on this. All right. So for the initial mesh, I'm basically at this point, I want to create like this connection right here between the in-between structure and the beams is not good. It's pretty bad, some might say. So what I want to do is create plates. Create metal plates that fill in this beam structure on here to have a welding area for this custom pipe to be welded to the beams. Oh, by the way, nice little thing is that the multi-pipe arrives at the beam at a basically a 90-degree angle. There might be a little bit of an error, but it's mostly 90 degrees. That's an added benefit to this kind of a workflow. Okay, so plates. Let's go back to our origin. Get it? The origin here. And let's insert our beam. Type in insert, and in Rhino, insert beam, hit OK, and type in 0, enter. Like that. Then here, let's just create a box on this end, right at the bottom, with the thickness of 10 millimeters. Like that. A very small box here, and also a box on the other side, 10 millimeters. Then we want these two boxes to be sticking out a little bit from the beam so that they're centered on the XY plane. So I'm just going to select both of them and move them down by 5 millimeters, half of their thickness. Like this. Select both of them. Type in block. Base point is 0, always 0. That's the way we model. And we name it plate. Or plates, whatever you want. I'll call it plate. There we go. So we have our second block, not instance, but not sure how to call it. Yeah, I guess instance. I guess we can call it instance. Definition, block definition. So we have plates. Okay. Where do we want the plates to be in? Well, I want the plates to be like these can be used as stiffening plates as well as the plates at the ends. First of all, let's add them at the ends. Or actually, one second. I'm thinking. Okay, so for these are the main lines, right? That we're using. So I can just say, give me a perpendicular frame as per usual. I'm basically just going to repeat this. So if you're lazy, you can just copy this, but I'm going to repeat it very quickly. Give me a perpendicular plate at 0, like that. Let's align the plate, or plane, align plane. This one with, I already have that vector. I will not be creating it anew. So that this is our kind of important vector right here. We align all of these and we rotate them 90 degrees, right? Rotate plane //90. Don't forget, never forget, right click, degrees, not radians, degrees. Important. Okay, so we have our plates here, and basically I can just go for orient. That's gonna be our orientation right here, right? And then I'll just use place block. Name of the block, plates. Did we use? No, we used singular plate. That's the name. Transform is the orient X, and bake is a button. A button. And if I were to, let's find, like, for instance here, if I were to bake it now, it adds the plates for welding. Great. We need the plates on the other side, and I kind of want the plates to be stiffening as well. So there's going to be more stuff that needs to happen here. Let me undo the plate bake. And let's just think. Okay, so perpendicular frames right now are only created at 0. So technically I could just say 0 and 1 and just have them working that way. But instead I will say not perpendicular frame, but perpendicular frames. Perp frames. Like that. It's going to ask how many do I want, right? And how many is going to be defined by, what's a line? Yeah, whatever. Doesn't matter, we're aligning them with align plane. So we're not using this. How many is going to be defined by the length of the line, right? So I'm going to measure the length. And I'm going to say, okay, so how often do we want stiffening for the beams? And I'm just going to say, let's go for length divided by every 500 millimeters. 500, bam. And then division output should be an integer number just to make it clean, integer, and we connect it to our n input here. So you can see the longer a beam is, more stiffening plates it's going to have. The shorter the beam is, less stiffening plates it's going to have. Then we align them. We just check if everything is okay. It seems like it's going to be okay. Press bake. And voila. Now we have the same beam, not beam, beam structure, only that it has the stiffening plates. And you can see, for instance, here that there is a misalignment, right? And that is going to happen considering that the curvature does need to be eaten up somewhere. So there are going to be instances where it's not misaligning, but where it doesn't connect at a 90-degree angle. It's a given. But more often than not, the connection is going to be pretty clean. Okay. Last one. We have this done now. Let's group it up. Last one is going to be the in-between panels. And for this one, I'm just going to do something very quick, very easy. We're just going to take our, where's our main mesh? Main mesh, hello? Yeah, there we go, diagonalize this one. I'm going to get face boundaries of that main mesh, like that. Let me just, again, wire display hidden, just so that it's not in the way. For the face boundaries, I'm going to create an offset, right? So you can't even see them anymore. Let me select everything and hide everything. There we go. Those are the boundaries, basically polylines. I will create an offset, but not any offset, but offset curve loose. I feel like loose is a better, it works better in this particular case. Then for every boundary, like that, I will offset it separately. So I'm grafting the input, right click grafting the input. For distance, I will be using, let's say, what's the thickness of our beam? Or actually, no, that's fine. Let's just do 100 or 110 millimeters. And let's create a negative value of it as well. So minus 100 and plus 100. Connect both of them, holding the shift key. Connect both of them to the distance. And you're gonna get basically offsets on both sides, right? And then for the plane, there's actually a little bit of work that needs to be done with this, because all of these are orienting in a weird way, so you can't really offset all of them in, you know, like the default plane. So just to make sure that it works, I will get the discontinuities of my curves, and I will create a plane fit through them, through the points that I've created, like that. This just makes sure that the offsets are always working. Usually it already does it exactly the same way automatically, but maybe it's a habit because it used to be a little bit buggy. Okay, now we get two options for both of these, and of course I want the offset inwards, so I'm just going to get the shorter polyline out of the two options, you know, the negative and the positive offset. So I'm gonna say length, measure the length, sort the list, like that. You sort the lengths, and together with the lengths you sort the curves as well. You create a list item. You get basically the first item of the list from the sorted curves, which is going to be, let me hide all of this, there we go. You get the panels, and if I mess around with the panels, they become smaller or bigger. You know, at a certain point, they will start self-intersecting like crazy. So you need to be careful with that. And then we just create a surface. There we go. As long as it's 4 edges, it automatically creates a surface from it. That's a nice thing. And that's it. That's your panels. We're not going to be detailing the panels as much. I don't think it's necessary. Right? So with this done, now we can actually work on the let's not calculate the distances. We can actually work on the shape itself, because at this point, if I were to show selected, show everything except the mesh, you know, this is what we have. Custom preview, swatch, white color, but with an alpha. Alpha is here, A. Okay, go to Arctic mode. For some reason swatch alpha doesn't work. That is okay though. You know, you end up having something like this. If you want the panels to be bigger or smaller, you can control it here. Right? Yay, yay. We are almost done. So now let me speed up the process a little bit, and I will just keep modeling. Let me delete all of this actually. Go back to shaded, show. I'll keep modeling this this one until I like it, and then we will pick up from there. Alright, so here's a little test that I've done with the tower, or the structure, I should say. Seems like most of it is working quite well. Let's go to a more complex area right here. Yep, seems like all of it is working quite well, quite as expected. All of the beams have their they're bracing, and it's just, you know, it's nice. Before we finish, again, available for Patreon supporters, this file. And also future explorations. So I guess I'm going to take like a portion of this structure and add it into, what's the word? Revit. I'll see how this can be replicated in Revit and how we can work with this in Revit. And also, for instance, here, like you will notice that my voice, god damn it, my voice. Right here, the beams are out of place, they are too big. So I would need to actually make them, make another flavor of these I-beams, smaller ones for smaller connections, right? And that's pretty easy to do. Just measure the length of the line, and if the length of the line is smaller than X, then you do a different I-beam type for it, right? So you separate the list into 2 or 3 or 4, doesn't matter. If you are curious as to how you would approach this with curved beams, I do have tutorials for them. Just go to my YouTube channel, type in curved beams Revit, rhino.inside Revit, and you'll find a script that does exactly the same thing as what we're doing right here with straight beams, so economy style. That script is going to be creating this kind of structure with curved beams instead. So perhaps that is going to be something that's interesting for you. All right, we're done. Next up, Revit. I'll see you there. Bye.